substitution rule, the substitution rule, the substitution rule. So this is one of the most important section, and we can use this throughout this course and even after Calc 2. So this is like pretty much everywhere. If you try to take differential equations and other classes, control theory, all those like engineering courses, so this technique is like pretty much everywhere, because this is gonna make most of the calculations very, very simple. So so what we're trying to do, before we kind of before we talk about the theory, let's try to look at a problem. So for example, let's say you have this one. Let's say you have 1 plus x squared square root dx. So if you look at this problem, and you can see that so we cannot solve this using the techniques that we know so far. Okay, so and there's no like easy antiderivative for this one, so you have to wait to do this kind of problems. We need to wait until what we call trig substitutions. Okay, so trigonometric substitutions, so we just call trig trig sub. Okay, trig substitutions. So that's the section that we do later. Now I'm going to change the problem slightly different. So let's say I'm going to do this one. I'm going to say 1 plus x squared. So we still have that term. What is the derivative of the inside function? The derivative of the inside function is 2x. So let's say I have 2x in front. So if we have a problem like that, this we can do. So that's the easy part. So if you see the derivative of the inside function, there is a shortcut method to do it. Okay, so we can so that's what we call substitution method. Okay, so we can discuss. So the method is what we call the substitution method. So what we gonna do? So substitution method. Substitution method. So what we're going to do, we're going to substitute u, just pick any letter, we're going to say u equal the inside function. Okay, we're going to pick u equal the inside function. Inside function is 1 plus x squared. So that is the trick. So we're going to pick u equal inside function. Okay, so that's the inside function. Okay, inside function. Now what we're going to do, we're going to take the derivative of both sides. Okay, so let's take the derivative of both sides. So if you take the derivative, so differentiate with respect to the variable, with respect to x in this case. Okay, x is the independent variable, so we have du over dx, and then here we have, if you take the derivative, you get 2x. Now what we're going to do, we're going to kind of think du by dx as a quotient, and we're going to cross multiply. We're going to multiply by dx both sides, so you get du equal to x times dx. So that is the tricky part. Okay, so we're going to consider simply du by dx as a quotient, because we know that actually that's a quotient, but we take the limit. The limit you write as du by dx. Remember, we normally do this is like a delta u over delta x, delta u over delta x, and take the limit when x goes to infinity, the limit when delta x goes to 0, and that is what we normally write as du by dx. So that is the idea. So now we kind of go backward. And think of du by dx as the quotient. Okay, so thinking that, so then you multiply, then you write du equal 2x dx. We always do that. Now what we can do is we can transform the problem. Okay, so let's go back to the problem now. So what I'm going to do, so let's look at the problem. So what the problem we have 2x 1 plus x squared dx. Okay, now what I'm going to do, you don't want to do that, but this is the first example, so I'm going to kind of show what are these steps, but later you really don't want to do this. Okay, so I'm going to move this 2x closer to dx just to show you what's going on. So once you do that, you can see what you see right here is exactly equals to du. So I'm going to replace 2x dx by du, right? Because that's exactly equal to du. And what is here? 1 plus x squared. That is simply u. Okay. So that means what we can do, we're going to transform the problem to the new variable. We transform the problem to the new variable and integrate under the new variable, because it doesn't matter how to do it. You know, the goal is to do the integral somehow. So what we're going to do, we're going to transform the integral into the new variable and integrate under that. Okay, so let's do it. So what's going to happen now? So you can see, so this simply becomes u square root dx 2x dx simply become du. Now you can see that you have a very simple integral in terms of the new variable. So you can see that the 2x dx whole thing equals to du, right? So that means you're going to replace 2x dx by du. And then now we have a new variable u, so we're going to finish the integral in terms of u, in terms of the new variable. So how to do this? Do the rest? U square mean u half. So u half means so we can do this as u. So half. So that means the integral become u 2/3 divided by 3 halves divided by 3 halves plus c. So in other words, this is 2/3 u 3 halves plus c. Now what we're going to do, you cannot leave the answer in u because that's something you introduce. So that means you need to substitute back into u. So let's do that. So if you substitute back into u, so you will get 2/3 u equal what? 1 plus x squared. You always have to do that. You need to leave in the original variable. The original variable is x. So it is 3 halves plus c, and that's the whole problem. So you can see that it's not difficult. But you need to figure out what is the substitution that you're going to make. So it's normally the inside function. And you can see that this problem is very simple. Okay? Very simple. So, but you can see that it's gonna make the calculation much simpler. Okay, much simpler. So, okay, so this is how you solve a indefinite integral using the substitution method. Okay, so I'm gonna do one more example. Just do one more example. So I'm going to do like quite a lot of example because this is one of the major technique and everyone need to excel in this. So let's do one more. So how about this one? So next example, find the integral of x cube cosine x to the 4th plus 2 dx. Okay, so the answer. Okay, can someone tell me what is the substitution at this time? Do you see the inside function? So what is the inside function? Inside function is, what is inside? It is x to the 4 plus 2. So that's the inside function that you're going to pick as u. Okay, because you can see that once you take the derivative, it is 4x to the 3rd. 4 is just a number. You can manipulate numbers always, but you're going to see the x to the 3rd. So that's the important part. So that means, yes, we can do it like this. Okay, so let's finish the rest of the problem. So we're going to say let u equal x to the 4th plus 2. then you get once you take the derivative, you get du over dx equal 4x to the third. In other words, so then you're gonna get du equal, so you take the derivative and then multiply by dx. That's what happens, because once you take the derivative, you get du by dx equal 4x third, 4x cube, and then you multiply by dx both sides. Okay, so that's clear. Okay, so these two are clear. There's a substitution, and this is what you get for du. So the important part is x3, x to the cube has to be there, is there. 4 is just a number, so you can manipulate that. So now let's see what's going to happen. Also, you can say that because what you see in the problem is x to the third dx, so you can say x to the third dx is 1/4 du. If you want, you can write it like that also, so it doesn't really matter how you're going to write it. Okay, so you can write it that way or this way. Good. So now let's do the rest of the problem. So what's going to happen? x3 cosine x to the 4th plus 2 dx equals, after the substitutions, so we have cosine x to the 4th plus 2 is u, so it becomes cosine u, and then you're going to combine these two. You're going to combine these two, that is 1/4 du. That is 1/4 du, so you're going to get 1/4 du. So the next step is, I'm going to pull the 1/4 out as a constant, so you're going to get cosine u du. Now what are you going to do? Now you're going to integrate with respect to the variable u. Okay, we can integrate with respect to the variable u. So if you do that, cosine means sine, not x, sine u plus c. Can you leave the answer in terms of u? No, we have to revert back to x. So what we can do, we can replace this one back from x, so it's going to be sine x to the 4th plus 2 plus c. Okay. That's the answer. So you can see that it's very simple, very simple. Good. So what I'm going to do now, I'm going to give you the formula. So there's like a substitution rule. So let's write the rule, and then we can do a few more examples. Okay, so you can see that it's very easy. Okay, very easy. So let's write the theorem. So it's a theorem. Just call the substitution rule. Substitution rule. So let's say if u equal gx, gx is that's the inside function. Okay, that's the inside function. U equal gx is inside function, is a differentiable because you have to take derivatives. Okay, differentiable function and whose range is an interval, whose range has to be an interval, so there cannot be discontinuities. Interval whose range is an interval I, and f is continuous. F is continuous on I. So f has to be continuous on that interval, in that range. Okay. Then what happened? Then the integral of f, substitute by gx, times g prime x, that's the du part, is simply equals to f, erase this a little bit, simply equals to the integral of f, you replace g by u and du. So what happened, you get the integral in terms of u, but this is much simpler than the original one. Okay, so if you look at the previous problem, you can see in this previous problem, x3 term goes away, you end up getting just 1/4 cosine u. See, it's the same cosine function, but you just have a u there. That's what it says. Okay, so that is the substitution rule, and then this is like very easy to integrate. So that is the substitution rule. So you can transform the problem. So what you do is you transform the variables from x to u. Okay, you transform the problem from x to u. Okay, this is like I mean, this is a practical situation. You know, maybe like, see, there's something that you don't want to eat, so what do? You sometimes add salt and pepper just to transform the problem to a different one that you can eat. So, right, this is a kind of similar idea. So then you can do it. You know, at the beginning, no, you don't want to do that. It's difficult. But what you do, you kind of change it. You transform it to something that you can manage. Okay, you transform that to something that you can manage. Okay, it looks like adding salt and pepper situation. Okay, so that's as a formula. But if we just look at the problem, it's much simpler. Okay, so but this is exactly what's happened there. So that means that g prime x term is gonna go away, and then you transform that to a new variable, and then under that variable the integral looks much simpler. Integral looks much simpler. Okay, so the situation is like this. You can see it's the same one, but it looks simple. Okay, but at the end you're gonna put that back in. Okay, let's do a few more examples. So the theory is over. How about this one? Another example. So let's say evaluate the integral 2x plus 1 square root dx. Okay, 2x plus 1 square root dx. So you already know what to do. So the answer, so let u equal inside function 2x plus 1, and then take the derivative, then du equal what? If you take the derivative, you get 2, so it's a 2 dx. Okay, 2 dx. Okay, so what's going to happen now? So your integral 2x plus 1 square root dx. So I'm going to do a small trick here. You see that you get a 2 dx there. You don't have 2 here. So what I'm going to do, I'm going to divide and multiply by 2. So I'm going to divide by 2 outside, multiply by 2 inside. Why we do that? Then you can easily it's a trick, okay, because the 2 get cancelled, so you can only do that. You multiply, divide. Now you can see that 2 dx is simply du, so that means your integral simply becomes now so 1/2 still there, and then 2x plus 1 is u, so it's a u square root, and then 2 dx is simply du, so that's du. Okay, so you transform the product to something easy. Okay, so this is very easy to integrate. So it is 1/2 integral of that is u to the 3/2 and divided by 3/2 multiplied by 2/3 u 3/2 plus c, and then you can see that 2 and 2 get cancelled, so you end up getting okay, and then you get 1/3. So your final answer would be 1/3. U is simply 2x plus 1 3/2 plus c. Okay, so that's the answer. Very easy. Okay. Now I mean, this is not the only substitution, so I'm going to give you I'm going to ask you to do this using another method. So so actually let's do that. Okay, that's okay. So let's say like another method. Okay. Another method. Let's look at another substitution. How about you pick u equal the whole substitution, whole integral inside, just the whole everything. So then what is the derivative? What's the derivative now? So then what's gonna happen? You have to use the chain rule. So du by dx. So this is half. So it's gonna be 1/2 2x plus 1 negative 1/2 times 2, right? By the chain rule you get 2, so the 2 and 2 get cancelled, so you're gonna get 1 over 2x plus 1 square root. Okay, so in other words du what do you get? You get dx equal what? So you get dx equal 2x plus 1 square root du. What is 2x plus 1? 2x plus an u, so it's become u du. Alright. This is just another method, but you can see this is a little bit complicated, but sometimes there are some problems you have to do that. Okay, so that's why I'm just telling you the method. So you're gonna get that. Now what's gonna happen? Let's look at the integral. So if you look at the integral, see these steps. So we have 2x plus 1 square root dx, which is equals to 2x plus 1 square root means u, dx equals to u du. So that means your problem becomes u squared du. Okay, so this u and the other u are different. Now you can still do the integral under this new variable. So you're gonna get 1/3 u3 plus c. Now let's substitute. So what is u? U is 2x plus 1 square root. Square means 1/2. So that if you raise to the power, you're gonna get 2x plus 1 1/2 cube. So it is 3/2 plus c. So you're gonna get the same answer, but this is slightly difficult. Okay, slightly difficult, but there are some problems you have to do this. Okay, so we're gonna discuss some problems later like that. Okay, but you can see you can still do it. So it's not just one substitution. Some substitutions are easy to work with, some substitutions are difficult to work with. So that's the whole point here. But you at the end you get the same answer. Okay, at the end you get the same answer. So these two are the same. Okay, that and that, it should be the same. Okay, you see it's the same. Okay, so let's do one more. Yeah, I want to do a few more examples like different types. Yeah, after we do this problem, we can discuss how to handle a definite integral, because these are all indefinite integrals. Let's do some definite integrals after this. Okay. Good. So how about this one? So find, let's say, x over 1 minus 4x squared square root dx. So so let's do the test. So what's the test? Test the inside function and the derivative. Do you see both? Do you see the inside function and its derivative? So if you see those two, then you can use the substitution method. That's the kind of test you do. You check whether the inside function is there. Yes, that's the inside function. What's the derivative? 8x. 8 is a number. We can always manipulate the number, but you have to have x there. So do you see both? Yes, inside function is there, and then its derivative is up there. Okay, so that means this is a good candidate for the substitution method. So let's do the rest of the calculation. So the answer. So that's what you do always. You check whether the inside function and its derivative, whether both are there, then it's very easy to do. Okay, that's if you don't see x there, this method does not work. You have to use some other tricks. So let u equal 1 minus 4x squared, because that's the inside function. Then if you take the derivative, then you're going to get du equal what? Negative 8x squared. So it is negative 8, not x squared, negative 8x, and they multiply by dx, so dx. So that's what you get. Okay. Okay, so that means the problem. So it is x 1 minus 4x squared dx. The negative 8, you can manipulate that, so you're going to have 1 over 8. And then we have negative 8x 1 minus 4x squared square root dx. Now this is very easy, negative 1 over 8. 1 minus 4x squared is u, so that means this is 1 over u square root, and negative 8x dx is simply, what is this whole thing? That is simply du. Okay, so that's du. That's du. Okay, so you can see this under new variable, that's what you get, and you can see that this is simply negative 1 over 8, the integral u to the negative 1/2 du. So you can just use the power rule. So if you use the power rule, you're going to get negative 1 over 8, and add 1 and divided by that, so that means u 1/2 divided by 1/2 plus c. Okay, and then divided by 1/2 means multiply by 2. So you're gonna get, after substitution, you're gonna get negative 1/4. U means that's 1 minus 4x squared, that's u square root plus c. So I mean, that's the whole problem. That's the whole problem. You can see it's very simple, not that long, but you still need to practice several until it's very, very clear to you. Okay, good. So good. So let's do a problem from exponential functions. How about this one? More the better. All right, because this, like I told you, like this is everywhere, so we want to make sure that you completely understand this one. When you look at the homework, you can see that the number of questions are different depending on the importance of the method and how useful they are. So this is another section that you're going to get a little bit more questions. So I'm expecting to give you about 15 questions for this one, and then normally the homework number of problems are about 8 to 10. Okay, 8 to 10, that's the normal number, or even less sometimes. I'm gonna kind of stay around 8 per section, but there are some sections which are really important, so I'm going to give you a little bit more questions just to make sure that you understand and you will not find any difficulty later. Okay, so that's why. So the number of questions are different every time. Okay, so let's do this. So calculate. Yeah, we use like different words for different time. So calculate e to the 5x dx. Actually, I'm going to change the problem a little bit. So how about let's add something, 5x plus 1 dx. Okay, the substitution is clear. So the answer, so let u equal what? When you get an exponential function, we normally pick the top part there. So we can say 5x plus 1, the whole thing as u. Okay, so then what happened? Du equal what? Take the derivative. So once you take the derivative, it is 5 and then dx. Okay, so that we have. Now we know what to do. Okay, so we're going to manipulate the integral now. E 5x plus 1 dx. 5 is not there, so 1/5, and then e to the 5x plus 1 is u, and then so we multiply by 5, so we have 5 dx. 5 dx is du. So right, 5x is there, 5 dx is there because you divide by 5, multiply by 5. So then go with that, and then this is what you get. This is very easy to integrate. So it is 1/5 eu plus c. So that means 1/5 eu means 5x plus 1 plus c. Very simple, very simple. Okay, I'm going to do a different type of problem right now. So I'm going to put a star here because this is like different from what we did before. Okay, this is different from what we did before. So so let's do that. I'm going to like even change the color. So slightly equal to what we did before, but not the exact same thing. So let's say find 1 plus x to the squared to the x to the 5th dx. So let's do the test. If we do the test, inside function, yep, that's clear. So you see the inside function, but do you see the derivative? Its derivative. What's the derivative of the inside function? 2x. But you can see that it's not x, it's x to the 5th. So there are some problems. So if you just have x, it's very clear. But there are some problems you can still use a substitution method to do. Okay, so that's the benefit of this technique. So let's see how it's gonna work. So here the inside function is I'm gonna write 1 plus x squared, and its derivative is 2x, but that's not what we have. Instead we have x to the 5th. So what we're gonna do, we're gonna x to the 5th, we're gonna change it to x times x to the 4th, and then x to the 4th you can replace by that again. So let's see how the argument works. Okay, so the answer. So this is a slightly different problem. Okay, so I'm going to put a star here. Yeah. So we still use a substitution u equal 1 plus x squared. Okay, and then take the derivative. Then we have du equal what? 2x dx. That's fine, because 2 you can manipulate. But now what's going to happen? You have x to the 5th. So what we're trying to do, from the x to the 5th, you can write this one as x to the 5th. You can write as x times x to the 4th. And then we're gonna leave this x for the derivative part. So we don't do anything with this x. Why? Because the derivative has a x. So we leave it. But what we're gonna do, we're gonna replace this x to the 4th by u. Okay, you're going to manipulate that. So what we're going to do, so the goal is we're going to solve for x squared here. So what is x squared according to this one? It is u minus 1. So what we're going to do, we're going to substitute for that. Okay, so here we're going to substitute. So we leave the x, no change, but x fourth you can write as x squared squared. You can write it like that, and then you can substitute. So it is x squared is what? U minus 1 squared. That's what we do. Okay, we're going to substitute u minus 1 is squared, so that means x. See, we don't do anything with x. This is u squared minus 2u plus 1. Now see what's going to happen to the integral. Okay, so that's the interesting part. So you're going to see the integral now is 1 plus x squared x to the 5th dx. So what we can do, the 2 is missing, so we have 1/2 here, and then we have 1 plus, I'm going to rewrite everything before substitute, so that's that term, and then we have 2x, why 2? Because 1/2, and then x to the 4th you replace by u square, yeah, so I mean you can write it like that, or let's write it the way we normally do. So we can write this one as x to the squared, that's what we did, and dx. Okay, so let's do all the substitution now. So it is 1/2. 1 plus x squared is u, so this is u, and then x squared is simply u squared minus 2u plus 1, and then you're going to combine these two, the derivative part you write at the end. So we leave that until the last moment because we know that this thing is simply du, so we're going to put du here. Du is what? 2x dx, right? The 2x dx, that's du. Okay, so now you can see that you transform the whole integral into u integrals. So okay, so and then what we can do is you can distribute. So let's distribute. If you distribute, you get u third minus 2u squared plus u, and then du. Now you do term by term. So if you do term by term, you get u fourth over 4 minus 2 third u third plus u squared over 2 plus c, only one c. Now you're going to substitute back in u. So if you do that, you're going to get 1/8. U is what? 1 plus x squared to the 4th power minus 1/3, 1 plus x squared to the 3rd power plus 1/4, 1 plus x squared plus c. Okay, so that's the answer. And you can see that for this problem, you really don't want to do this way. You can do it just distribute through, because you can distribute by 1 plus x squared, you multiply by x to the 5th, and then you get 2 terms. So you can do that, but that's not the whole point here. I want to show you how the trick works. So for example, what is the answer for this problem? So this is an exercise. It's an exercise. So so find 1 plus x squared square root, I mean something else, you know, yeah, square root, or let's say not square root, let's say 3/2, and then x to the 5th. Dx. Okay, so So this is also an extra credit problem. So you can, this is problem number 2. Okay, so exercise, this is the extra credit problem 2. So you can do them and send it to me through an email, and then I'm gonna consider them at the end of the course in case. Okay, so extra credit number 2. So do it and email me. Again, you can see that you can use the exact same substitution for this problem as well. You can use the exact same substitution, it can work. Okay, you can pick the inside function 1 plus x squared as u and just do so this is the whole point why we want to do it this way, but otherwise this problem you can do in a different way. Okay, you don't need this method because you can just distribute and then do, but that's not the one. I wanted to show you how to handle a different type of problem using this trick, but you can see that that technique now you can apply for this kind of problem as well. Okay, so why don't you do it and send me. Okay, good. So let's try to do a different problem where we're gonna have some like a formula that is in the big large table. So how about this one? So we're gonna prove this formula. We're gonna prove that so let's say formula. So this is a new formula that we're going to prove. The formula is, there are two formulas actually. One is tan x dx. So tan x doesn't have a formula yet, but you can prove that this is simply ln secant x plus c, and then the integral for cotan x, you can show that this is ln sin x plus c. Okay, so we're gonna prove these two formulas right now, and then after that you can use this. So this is a formula. So let's do that. Get the proof 1 and 2. So let's do the first one. So so this is the trick. So it's very simple now. So what we do, we're going to start with tan x dx. Tan is what? Tan is sin x over cosine x dx. And now what we can do, we can use a substitution. Okay, what's a substitution? We're gonna let u equal the bottom function cosine x. Why we do that? Because the derivative of that is the top one. Okay, so then the du is what? Negative sin x dx. Negative is just a sign, so you can change that. So that means you can change this problem negative negative sin x over cosine x as we did before. Now we're going to use a substitution. So once you use a substitution, what's going to happen? Negative negative sin x dx is du, cosine is u. Can someone tell me what is this integral? This is exact like dx of x. It's just a different variable. If you have dx over x, what do you get? Natural log x, right? So in this case, what you get is natural log u. Okay, so that means your answer becomes negative natural log u plus c. Okay, so let's put that back in. So that means a negative ln, what are u? Cosine x. Do you remember what the negative sign does? So negative sign means the power, is that right? That's the power. So it's a negative power. That means if you bring it inside, what's going to happen? This simply becomes ln, that's the power. So that means it is cosine x to the negative 1 power. That means it is 1 over, so it becomes secant x. 1 over cosine is secant. So that's the that's what's happened, because cosine x negative 1 means 1 over cosine. 1 over cosine means secant. So that's the proof. So you can see that it's not that difficult. It just go along very easily. And similarly, you can prove the second one. So what's going to happen? It is cotangent x dx. Cotangent means cosine x over sine x. And in this case, you can take u equals sine x. So the derivative become du equal cosine x dx. That's the derivative. So that means your problem you can write as du over a u. Okay, so this is du over u. So that means ln u plus c. So that means ln u equal sine x plus c. Okay, so that's the proof. So you can see that it's very, very simple, and you can use them in the future. So if you get a problem, so we can use this a lot. So this is another formula, and then you can see that that is in the 22 table that I gave you Monday. So now we prove them, you know how it works. So how to prove it? We use a substitution technique to prove them. Okay, so make sure that you remember the formula. Okay, so integral of tan x is natural log secant x. Integral of cotangent x is natural log sine x. Okay, so and then how you to prove it? This is how you prove it, but this formula, so you can use them in the future. Okay, now what we're gonna do? We're gonna go. We're gonna move on to something slightly different. So what we do? We're gonna study how to do definite integrals. Okay, we do definite integrals. So okay, so yeah, actually what I can do is I can yeah, I know actually that's okay, we can put in one lecture. Okay, so let's do the next one, definite integrals. Definite integrals and definite integrals and substitution method. Okay, definite integrals and substitution method. So when it comes to definite integrals, the things are slightly different. Actually there are two ways to do this problem. So one is like, you can just do the problem as it is, and then at the end you're gonna substitute the values. So let's do a problem like that. So the method 1, I'm gonna call it method 1. Method 1. So it depends on the problem to problem. So so let's do this problem. So let's say 0 to 4 2x plus 1 dx, and then actually this is a problem that we did before. So what's gonna happen? We did 2x plus 1 before, so I hope you remember the answer. That was the one of the early example. So according to that, what do you get? So so you get 1/2. You can look at the answer. You get actually 1/3 2x plus 1. So you finish the integral as we did before. So this is what you got. And then what you're going to do, you're going to substitute the values. You're going to substitute 4 and a 0. So you can see that you don't need to add plus c when you do definite integrals, because that's going to get cancelled. Okay, so when you do definite integrals, we do not add the plus c, but if you do indefinite integral, you have to add the plus c. So that's something. Okay, so no plus c, no plus c. Okay, so because it's going to cancel out, so we don't need that. Okay, so let's finish. So that means what you're going to do, you're going to plug in 4 first. So it is 1/3. You're going to plug in 4. So you plug in 4, what do you get? you're gonna get 4 times 2 plus 1, that means 9 3/2 minus, if you plug in 0, this is 1 3/2. So that's 1/3. So how much 9 3/2? 9/2 means 2, and to the cube is 27 minus this is 1, so you're going to get 26/3. That's what you get. Okay. But I'm going to show you a different technique as well. So before that, let's discuss this formula, and then discuss the method. So what's the theorem? So I'm going to write the theorem. So what the theorem? Substitution method for definite integrals. For definite integrals. Substitution method for definite integrals. Substitution method for definite integrals. So let's say, so what's going to happen if g prime is continuous? If g prime is continuous on AB and f is continuous on the range of u equal gx. So what's going to happen when you have integral a to b f gx, the inside function, times its derivative? This is simply equals to, you do the integral in terms of the new variable and simply substitute the g of b and g of a. So evaluate at g of b and g of a. So that means you do not want to go back to the new variable, as I says. Okay, you don't want to go back to the new variable. What you do instead, calculate the finish the integral under u. Okay, so that's the method 2. So let's discuss that here. So I'm going to say method 2. So sometimes the method 2 is much faster. So let's do the same problem. 0 to 4, 2x plus 1 square root dx. So what's going to happen? I'm going to do this calculation, back calculation here. So what is that? So u equal 2x plus 1. That was substitution. And then we calculate du, which is 2 dx. Now what we're going to do, we're going to calculate the new variables of u. So what happened? Here the variables are for x, so we're going to calculate this. So that means we have x equals 0, gonna corresponds to what? When you say x equals 0, what do you get? You get u equal 1, right? When you substitute x equal 4, that's the top limit. You have to plug in the limits to the substitution. So when you plug in x equals 0, you get u equal 9. Because that is the extra step that we want to do. We want to calculate these two numbers. Okay. Now let's finish the problem under this new technique. Okay, so what's going to happen? So let's do it. So this is 2x plus 1, 2x plus and u, so this is u square root, and then dx is what? Dx is 1/2 du, so it's a 1/2 du. Now what you can do? Now the new variable, here the variable is x, now the variable is u, so you have to put the u limit. What are the u limits? 1 and 9. So that is the new technique. Okay, so we don't go back to the original variable, so we stay with u because it's much simpler. So now you finish the integral. So it's a 1/2, 2/3 u 3/2, and then 9 and 1. So you can see it's the same thing. So it is 1/3. So with 9, so 9 3/2 minus 1 3/2. This exact same calculation that we did before, but it's much faster. It's much faster because we even solved the whole problem inside. So this is much faster. So you're gonna end up getting 2/3 26/3. Okay, so it's the same thing. Good, very good. So let's do so remember, so I did both in the same page just to compare the two. So what's gonna happen, you do not go back to the original variable. What you do, you're gonna finish the problem inside within U. Okay, so but it's up to you how you're gonna do it. So what are the two methods? First, you finish the integral in terms of the original variable and use the original limits. Okay, use the original limits. So that's what happened here. So use the original limits 0, 4 and 0. Or you can do the integral in terms of the new variable and use the new limits. Okay, so but you can see that at the end you're gonna get the same answer, but sometimes the second method is much faster compared to the first method. Okay, because especially when you do solve long problems, it is much better to use the second method, then you can save a lot of time. But make sure that you calculate the new limits. Okay, so you see the limits change now. Okay, so let's do maybe one more example. Yeah, just do one more example, and then we have one small thing, and then we're done. Okay, so let's do actually two more examples, like I do like quickly. So yeah, I told you like this is like important technique as problem that we need to do. So evaluate 1 to 2 dx over 3 minus 5x to the squared. Okay, so again this is a definite integral. So the answer, so we're gonna say u equal the inside function 3 minus 5x, and then we're gonna calculate du equal, what do you get, negative 5 dx, and then the limits. So when x equal 1, u equal, how much you get when x equal 1? X equal 1, you get negative 2. And then when x equal 2, that's the other limit, that's the upper limit, lower limit, upper limit. U equal, if x equal 2, u equal negative 7. Okay, those are the new limits. Okay, so let's go back to the problem. So it is 1 to 2 dx over 3 minus 5x squared. So this can change now to so what do you get? So I need like a little bit more space here. So you're gonna get negative 1/5 negative 5 dx over 3 minus 5x squared 1 2. Now let's change the new variable. So it is negative 1/5 negative 5 dx is du, and then 3 minus 5 is u, so it's a u squared. Now it's a variable is u, so that means you have to put the new limit. So it's a negative 2 and negative 7. Whenever you change the variable, change the limit. Okay, it's important, otherwise wrong. Okay, now like we can finish the integral. Negative 1 over u squared. So 1 over u squared you can write as u to the negative 2. So we use the power rule. When it's a power rule, it's become negative 1 over negative 1. So, right? So that means this is simply another negative sign that make it become positive 1 over u. The limits are negative 7 and negative 2. That's it. Okay. So if you simplify, you're gonna get 1/5 negative 1 over 7 minus minus plus 1/2. So so you're gonna get 1/14. That's what you get. Okay, so you can see this much faster. You did not go back to the original variable, and you finish the problem within the new variable. Okay, that's what I want to do. So okay, so let's do another last example of this type. So example, calculate 1 over e ln x over x dx. So how about this one? So this is like an interesting problem. So the answer, let u equal what? What's the inside function? Do you see a function and its derivative? What is the function? Is that x? No, its derivative is 1, so that's not going to work. What is the function? Function is ln x. ln x. Be careful when you have log and 1 over x, that's always substitution. So then du is simply 1 over x dx, because derivative is 1 over x multiplied by dx. Okay, and then also we calculate the new limits, and then x equal 1 gives what? X equal 1 gives u equal ln 1, which is 0, and x and x equal e gives u equal ln e, which is 1. Okay, which is 1. Okay, so okay, now let's change the problem now. So we're gonna go 1 to e ln x over x dx. So it is ln x is u, ln x is u, 1 over x dx. So we have 1 over x dx, that is 1 over x dx. 1 over x dx equal du. Perfect. And the limits are 1 becomes 0, e becomes 1. So this is now u squared over 2, 1 and a 0. So you plug in 1, you get 1/2, 0 means 0, so you get 1/2. Okay, so very simple, and that's the whole integral. Okay, so we're gonna practice similar ones in the homework. You can see that it's not that bad, but make sure that you look at this couple of times until it's very clear. Okay, so that's pretty much about the substitution method. But I want to show you like some small thing. So what's gonna happen? When we have odd function and even functions? This is like a slightly different topic, but let's discuss that because this is like kind of interesting. So we can talk about symmetries. So symmetry. Okay, symmetry. So what's gonna happen? Let's look at a like a problem like that. This is what we normally call odd function. What odd function means? The value at the negative value is the opposite of the positive value. You see that value is there, that value is there. So the odd function means value at negative x is equal to negative of the value. That's odd function. What's the even function? What's the even function? Two sides are equal, right? So the negative value and the positive value are the same. That's the even. That means f to the negative x is equal to f to the x. So what's going to happen in this case? If you have an odd function, the integral becomes 0. If we have a symmetric integral, so like negative 1 to 1, negative 2 to 2, like that, it becomes 0 because they cancel each other. In the even one, it's get double. Okay, so let's write this result. So integrals of symmetric functions. Integrals of symmetric functions. Integrals of symmetric functions. So integrals of symmetric functions. So suppose f is continuous on a negative a to a interval, negative a to a, symmetric. Okay, negative a to a. So negative a to a, like that. So what it says, the first one, if f is even, if f is even, what's gonna happen? If f is even, what's gonna happen? The integral from negative a to a fx dx is equals. So what will happen if you take the integral from negative a to a, the whole integral, it is double of 1, is that right? Because it's two areas, you can add it up, so you can say twice 1 of them, 0 to a fx dx. It's very clear from the figure. Okay, so it's clear, that's that one. And if you look at the other one, if f is odd, what will happen? Negative a to a fx dx. In the previous one, if it's odd, they cancel each other, because one is positive, one is negative, they cancel each other, you get 0. Okay, so that is what happened when we have symmetric integrals. Let's just do one example like that, just to figure out what's going to happen. So let's say let's look at this problem. So exercise, this is the last one. So you can say, example, find the integral from negative 1 to 1 tan x over 1 plus x squared to the x fourth dx. Yeah, if you just try to do this integral, it can be very painful, because very difficult to do, but you can figure out something. What do you notice? So the answer, let fx equal tan x over 1 plus x squared x to the fourth, then f is odd, since tan is an odd function. Tan is an odd function. Why tan is an odd function? Look at the graph of tan, it just looks like that. So that's an odd function. And 1 plus x squared plus x to the fourth is even. So when you have odd function, even function, when they divide or multiply, because the even function does not change anything, so that means tan function gonna give you the property. So that means if you multiply or divide even function and an odd function, the result is odd. Okay, so odd function. So according to the previous theory, we know that if the function is odd, when you take the symmetric integral, it's gonna be simply 0. So I mean, that's it. That's the only thing you need to notice, because you see that it's simply 0, because f is odd function. It's odd function. Okay, remember, like, when you divide odd function, even function, it's odd, because even function does not change anything, so it's simply the properties of the odd function. So so if you multiply two odd functions, still odd. Okay, so what happens when you multiply two odd functions? When you multiply two odd functions, and then when you divide two odd functions, just think about it. Okay, so because even function does not change anything. But if you have odd function, what will happen? So what odd function means, it's going to change the sign. So so if we have two odd functions, what will happen? The first one change the sign, the second one change the sign, so that it become an even function. If you multiply, or if you divide two odd functions, it's become an even function. So, right? If you multiply two odd functions, it's become even. If you divide two odd functions, it's become even, because you can show that both the top and bottom get the negative sign, but they cancel each other. But if you have odd and even, it's simply the properties of the odd function works, because even function does not change it. Okay. So I can write it here. So what happened? Odd times odd is even. This for functions, okay, not for numbers. Numbers, it doesn't work that way. Okay. And then odd function divided by odd function is an even function. Okay, but when you have odd and even, it is odd. Okay, so odd, even, odd. Odd divided by even is odd. Okay, so when they have different, it is odd. When they have same, it's even. That's the easy way to remember that. Okay, so thank you. So this is the end of the substitution method. I will have like a short video to show you some applications of the substitution method. For example, how to find area. So I might like put like 4 examples, very short video with 4 examples to show you like how to apply these techniques when you do area problems, but that you can expect sometime soon. Okay, so thank you so much. So this is the end of the substitution method. Make sure that you go over this video several times until it's very clear. Okay, because this is useful everywhere. This, so there shouldn't be any doubt on this one. Okay, so thank you so much. So we're gonna continue next week. We can do volumes. Okay, that's the major topic in this calculus 2. We can talk about volumes in the next lecture. Thank you.